And welcome everybody to the Daily Space Weather. Today we're looking at the coronagraph located at stereo A at Lagrangian point 5. And there is a coronal mass ejection event occurring as we make the video. We'll have to create another video later to document this further. Nothing Earth-facing currently happening. But you can see some ejecta coming out here. And that planet down there, that is Mercury, if you were wondering. No Earth-facing ejecta at this point, but there could be something in the Earth-facing vicinity coming here. And the likelihood for additional ejecta coming out of these areas is certainly there. So if you want to learn more about stereo A, by the way, you can check out their website. It's stereo.gsfc.nasa.gov. And if you click on what did I click on there? If you click on the all right, I have no idea. But in any case, stereo has links to identify the stuff on the imagery. Here's a link, what planets are currently visible. So let's take a look at the sun here in multiple wavelengths. Here it is in 211, 304, and 171 angstroms. There is only one sunspot. It's quite small, and we'll show you close-ups of that momentarily. And if you weren't aware, I'm your host, Dan, a.k.a. smAsho. Today we'll also be talking about a new volcanic fissure opening in Iceland, geoengineering and climate, and how about some PeVatrons? Yes, PeVatrons. All right, so back to some more solar imagery here. Here is a close-up of sunspot 2813 in 304 angstroms. No solar flares happening. Once again, another perfect example of coronal mass ejections occurring with no solar flaring. We'll also show you the 171 angstroms wavelength for that same region. Again, sunspot 2813. And we see some magnetic migration happening as well. Here's the magnetogram. So the primary umbra there, which is North Pole oriented, has remained pretty stable here over the past 24 hours. You can see a little bit of migration of the magnetic fields behind that leading North Pole umbra. Here's a diagram of the solar system, if you're wondering, which means that stereo A is located right about there, quite close to being perfectly in line with Mercury. Stereo B is located someplace like here. Those are Lagrangian points 5 and 4, respectively. Here's a star chart, and if you're up before dawn, you may see the Moon and Saturn side by side near the ecliptic. That's the Moon, and that's Saturn. I don't know why I have to click it so many times, but there you go. The radio flux only at 72, as the upper chromosphere and lower corona emit radio frequency. The radio flux, the most proportional data set to the sunspot number. Here it is on a 1-year chart. The top line there, the black line, that's the 10.7 centimeter radio flux. Again, only at 72, and the sunspot number is this lower red line. We don't see any NOAA forecasts for any sort of geomagnetic activity here over the next 3 days. And here's the new fissure that's opened associated with PeVatrons. This is the cinder cone way over here. And you can see this lengthy fissure. I think it's about 1.5 kilometers in length, which has sent hikers scrambling. This is live footage, by the way. And here's some footage of the main caldera. The Fagradalsfjall caldera, yes, fantastic imagery. As the crater valley continues to fill up with lava. You can see some steam venting coming out there right near the peak of that portion of the cinder cone. And there's a phys.org article about it as this new fissure opens up. So it's about 500 meters long there, folks, about 550 yards long, and about a kilometer from the original eruption site. Immediate evacuation of the area has been announced, and it's not expected to affect air traffic. That's a good thing. And you can find this article in the phys.org's Earth section. Let's see what else has been erupting over the past 24. And there's the article about the new fissure opening on the Reykjanes Peninsula. Suwanosejima also erupting, flight level 050. It's producing a 5,000-foot ash plume. Dakono exploding, 7,000-foot ash plume. Veniaminoff on the Alaskan Peninsula has raised the aviation color code to orange. So that's because of seismic activity being elevated there, folks. Sangay in Ecuador also exploding, flight level 190. It's a 19,000-foot ash plume. Revenador, also in Ecuador, exploding, 15,000-foot ash plume there. And Sabancaya exploding as well. Intermittent emissions are enough to produce a 27,000-foot ash plume. And I'd like to remind you not to pole vault the caldera. Check out our own website if you haven't, smashamash.com. We saw the writing on the wall years ago. As big tech self-destructs, we have decided to construct instead. So again, check it out. And if you click on this link right here, smAsho merch, you'll get redirected to our Redbubble shop. Today's featured product is the Do Not Pole Vault the Caldera socks. You may be surprised at the quality of the prints. It's very high quality. And check out the resolution, folks. Look closely. It's seamless. And the reason the sides of the no symbol are cut off is because we made it gigantic for your favorite t-shirt. Or, well, check out the rest of the merch by clicking the link at smashamash.com to the smAsho merch shop and perhaps pick up some fantastic Do Not Pole Vault the Caldera merch. It also has the link to the YouTube page as well as to smashamash.com on those products. Let's move into seismicity. Wondering which earthquakes have been occurring? Where earthquakes have been occurring? Well, here's the list. Shout out to Nabo J, one of our patrons. Have you felt any further earthquakes there? Nay says she felt this 4.0 at Lenox, California, prompting us to put up a community post on YouTube. Small deep quake struck Dominica, the Caribbean island there, the Dominican Republic, the Isle of Hispaniola. It's a 4.0 magnitude at 117 kilometers depth. So looks like the largest of the past 24 was only in the 5 magnitude range, folks, so no major quakes over the past 24 hours. Small deep quake struck Peru at a 4.4 magnitude at 150 kilometers depth. Another deep quake at Argentina, over 240 kilometers and a 4.6 magnitude depth. Another 4.6 magnitude deep quake at Argentina. And continuing up the list here, let's continue on with solar data and the X-ray flux. No solar flares of note here, not even making it into the B-class range over the past 3 days. One small flare almost made it, and we don't see any proton strikes as there are no coronal mass ejections striking the magnetosphere. Here's the GOES magnetometer over the past 3 days. And Earth is solidly in the South Pole current sheet. We'll show you that momentarily. And here's the latest imagery. It's the top view ecliptic plane field plot. You can see here the red area is the South Pole oriented current sheet, folks, the portion of the current sheet that is polarized to the south solar polar field. And again, there is some plasma in between Earth and Sun. You can actually see these bunched up images here. See that bunched up set of potential field surface source lines? That is a large plasma plume in between Earth and Sun, and that could eject, which is what we've been talking about when we've been listing the coronal mass ejection watch. Here's a line of sight coronal hole plot, which doesn't show any coronal holes, and it shows you the Sun's B field in blue. You can see the solar polar regions there in green and red, north and south pole respectively. And here's our new feature here, the line of sight ecliptic plane field plot. And this wavy blue line here, this is basically showing you the BZ that we show in the real-time solar wind. And what we mean is, when this is down here, the portion that the Earth is in contact with, that would be a negative BZ. When it's up here, it's a positive BZ. That blue line is a reference to the solar B field. And the rest of it is basically just a three-dimensional view of the current sheet. And the Earth orbits the Sun very close to the solar equator on what we call the ecliptic. KP index currently at 0 for the past 6 hours. And for you new viewers, thanks for tuning in. The KP index is a measurement of global geomagnetism. And if you've got theories as to how it's generated, please leave us a comment, or perhaps go post at smashamash.com/forum in the Earth and Geophysics section. Next, we'll look at the real-time solar wind to see this weak coronal hole wind stream subsiding. And we saw exactly what I forecasted here, a downtick in the solar wind density with an uptick in the solar wind speed. And with the uptick in solar wind speed, you see an uptick in the temperature here of the incoming solar plasma. It's a weak coronal hole wind stream. And we're seeing another minor pulse here. Current solar wind density just over 10 protons per cubic centimeter. Solar wind speed 313 kilometers per second. I think the same as we reported yesterday. It's solar minimum conditions, except for that density. Here's a visualization of the density. It's our Geospace magnetosphere movie. And it's 4 hours of data. Since it refreshed, we'll let it play through here. Keep in mind, folks, this imagery shows you high density in dark blue and low density in white. And we're expecting fairly low magnetohydrodynamic pressure here with that low solar wind speed. So here's the pressure. And you can see some pressure caused by that density out in the bow shock region, which would be on your left. And what you're seeing here are two 90-degree turns of the Earth here. So the equatorial plane is as if you're looking down at the Earth from the pole. And the meridional plane as if you're looking at the Earth from the side, as if you're on the ecliptic plane. 4 hours of data, space weather modeling framework. Here is the Geospace Delta B, also 4 hours of data. You can see some perturbations here over the Canadian North Pole, less so over the Siberian one. Yes, we have two. And not a whole lot of changes in the southern B field there, as the South Pole has left the Antarctic continent and is someplace down here, south of Australia, thousands of miles from the geographic pole. By the way, we do regularly stream live to Twitch. Thanks to our Twitch viewers. It's twitch.tv/smashamash. We're not currently streaming live, but we will in the future. Thanks to our YouTube viewers as well, youtube.com/smashamash. The majority of our content is there. Don't forget to check out our playlists, youtube.com/smashamash/playlists. Were you aware that there's an article on SciTech Daily about experiments showing that sunlight destroys COVID 8 times faster than scientists previously thought. You hear that, COVID? Yeah, sunlight. We reported on this over a year ago. You probably weren't watching our videos back then. Congratulations on finding them now. And so I'm going to let this article scroll here, this SciTech Daily article, about how ultraviolet light destroys COVID viruses. Who knew? Well, everybody who was following our content certainly knew about it. We made entire thumbnails just based on the fact that sunlight destroys COVID. Apparently, it destroys it even better than we thought. Who would have guessed? And I'm just going to let the article scroll here so you can read it without leaving our video. And we'll ignore that article. I don't know how we got on it in the first place. But you better return control. There we go. Congratulations. Thanks to our BitChute subscribers. If you haven't checked out our 400 BitChute subscriber special, go watch that. It's exclusive. There is more exclusive content as well, like our hydroxychloroquine video. And let's live stream for our cosmology segment. Yes. So we've decided to live stream this portion of the video to Twitch. Again, twitch.tv/smAsho. Today's cosmology segment is quite interesting, actually, as are all of our cosmology segments. And again, there's a playlist of these at YouTube as well, youtube.com/smashomash/playlists. You'll find over 150 videos in there. How about photons with monstrous energies coming from the galaxy's largest accelerator? Now, we've got some large accelerators, such as the Vela pulsar, the Crab pulsar, and other pulsars within the Milky Way galaxy. Some of these are accelerating protons to relativistic speeds. And when those protons smash into things, they create very, very high energy photons, known as PeVatrons. Yes. So photons with energies of about 200 tera electron volts, known as PeVatrons, are coming out of these clouds of dust. Are they coming directly from the accelerators? Well, not really. They appear to be coming from the accelerators in that the accelerators are blasting particles into other fields of gas, which are emitting these incredibly high energy photons. And that's what that article's about. And this particular one we're talking about is BDS 2003 is the source of that. You can see it on the imagery there. It's in a very bright spot there. And the pulsar is HAWC J1825-134, if you were wondering. How about some unusual flaring activity observed from the ultra-luminous X-ray source NGC 4559X7? So there's a very variable ultra-luminous X-ray source located in that galaxy. And that galaxy is pretty distant here. This one is located at a distance of, well, I have no idea, but I'm just going to let this article scroll as well. NGC 4559's X-ray source X7. So these kind of sources are less luminous than active galactic nuclei. And we're going to show you some imagery of NGC 4559 momentarily here. And the luminosity reached a maximum of about 60 duodecillion ergs. So the peak of the flares, the luminosity was a factor of 3 higher than the pre-flare luminosity. And if you want to read about that, that one is on phys.org as well in the Astronomy and Space section. There's nothing random about it. Here's NGC 4559. A quite lovely galaxy here. We're going to look at it in a few wavelengths. And check it out on Pan-STARRS. The detail is vast. And this extremely bright source here, this is some sort of a satellite galaxy That's probably not X7, folks. And what we were originally showing was Galax. This is the UV spectrum. Great view of that. And let's show it on Chandra. Here is the Chandra X-ray telescope, and you can see that very bright X-ray source there. And the satellite galaxy probably has its poloidal field directed toward Earth. Otherwise, it wouldn't be so bright, as it is a small galaxy there. It could be a quasar in the background, too, but I think that is a satellite galaxy. And last but not least, here is NGC 4559 in the 2-mass infrared light. Fantastic view there of Galaxy 4559. And that's today's cosmology segment. We streamed this live to Twitch. And Twitch viewers, please consider becoming a patron if you want to see the daily space weather videos on time. Thanks to everybody else who tunes in. And that's today's cosmology segment. And let's get back to some regularly scheduled space data. Here's the electron flux over the past year as reported by Solon.info. That's 1 year of the electron flux. Here's the 3-day chart of the electron flux, and we see quite low levels here, as we've seen some weak coronal hole wind streams striking the magnetosphere. Here's the forecast model. You can see the green boxes are the forecast, the yellow diamonds are the observation. No real surprises there, as solar activity has been ultra weak over the past non-ultra week. Here's a diagram of the Van Allen belts. Since we're talking about electrons, keep in mind that the distances here are in miles. And here's a visualization of the total electron content. This is the entire air column in terms of electron density. And this will show you where GPS errors are most likely to occur, which is typically around the equator at noon. Although when we see very low levels of electron flux, we're more likely to see anomalies at nighttime. You can see here a little bit less organized electron belts. And that is typical when we see coronal hole wind stream strike. And we don't need to go more in depth into that. Here's another diagram of the atmosphere. It shows you things like the troposphere, where all your weather occurs. Penetration of electromagnetic radiation. And over here, this red F is the F layer of the ionosphere, which we're now showing you. So here's the vibrational frequency of the F ionosphere layer at about 300 kilometers of altitude. And what we're looking for here is for large anomalies. And so we show this daily to chronicle the data. One of the many benefits of our daily space weather videos. And I think we're pushing 700 in the playlist, as we've been doing this for about 3 years. And there are even more daily space weather videos that aren't in the playlist. If you haven't checked out our older content, if you're interested in what was going on a certain day, check it out. And there is the ionosphere, looking a little bit surprisingly charged up in the southern hemisphere, even though it is now fall. So anyway, here's the latest image coming in at 9 o'clock Universal Time. And we're going to do some meteorology stuff here. Here are the jet streams of the Western world, quite concentrated over the North Atlantic, and quite split up and divergent over the U.S. Some extreme bends in the southern hemisphere. Here are the jet streams of the Eastern world. And we rotate that just far enough to see New Zealand. Some pretty chaotic jet stream flows in the south as well. Let's talk about geoengineering, one of the stupidest ideas in the history of mankind. How about a sun reflector for Earth? Scientists explore the potential risks and benefits of being a moron who thinks that carbon dioxide controls the Earth's climate. An absolutely idiotic idea. Now, if you're wondering about my resume, I started studying climate in 1987 in my 8th grade Earth Sciences class. And while I'm dating myself, people should get their schist together and understand the way climate works. The geologic record tells us there's absolutely no way that carbon dioxide runs the Earth's climate, and yet imbeciles in the media who know nothing about physics are probably trying to convince you that carbon dioxide is a pollutant. Carbon dioxide is not a pollutant, folks. Carbon dioxide is the most important trace gas in the world, and it is at the base of every significant food chain on planet Earth. Attempting to reflect solar radiation back into space to cool the planet is just about the stupidest idea in the history of mankind, as cooling is a positive feedback mechanism and warming is a negative feedback mechanism, and no more about that, but that article is from phys.org in the Earth section. Here's another one in the Earth section, which refutes the original one, talking about how solar variability determines the onset of La Nina events. So there's less than a 1 in 5,000 chance that the sun is not responsible for La Nina events. And guess what they're talking about? Yes, the solar polar field reversal cycle, the 22-year full spectrum solar polar field reversal cycle, not to be confused with the 11-year solar cycle. The 11-year solar cycle is the sunspot cycle. The 22-year cycle is the full solar polar field reversal cycle, which is really just 2 sunspot cycles, as the solar polar fields flip each time. And guess what? Stretching all the way back to 1960, El Nino and La Nina events coincide with the 22-year solar polar field reversal cycle, which is one of the many reasons why we're going to write a paper to explain the solar polar field reversal cycle and the mechanism behind it. If you don't think I'm serious, well, just wait until the paper comes out, and we'll make a video about it once it gets submitted for peer review. We're sure you'll all enjoy that, as it will be groundbreaking. And let's continue on here to look at pressure cells. Here are pressure cells where they are now. Here's where they'll be at 1 p.m. Eastern Time tomorrow. And if you're wondering where we're located, it's right about there in Lehigh Valley, Pennsylvania. Right about there, just west of New Jersey. And next, looking at a real-time lightning map. I like to use lightningmaps.org when I hear thunder. It helps me to convince my foes that I'm Thor and that I'm causing the thunder. And we see some lightning here in northern Michigan. Actually, Wisconsin. Hey, Waterloo, there's thunder rolling in. And I don't know why we zoomed in on Antarctica there. There's some reason for it. I pressed the back button. Anyway, there's your global lightning map. Here's a U.S. Doppler radar map. Some more snow falling in places like Wyoming, Idaho, Montana, and Utah. Here's a U.S. cloud cover. It's 3.9 nanometers radiation. And here's the water vapor map. Again, there's cloud cover. And there's water vapor, complete with a Borg sphere flying in between the GOES satellite and the Earth. As this rotating low-pressure system here just sits off the coast of Cape Cod, stagnating. And it's actually going to remain there here. No input to really move it at the moment. And how about some bonus features? Here is the latest imagery from Udaipur, India, in hydrogen alpha. You can see some filaments here all around the southern hemisphere as well as up here in the northeast. Again, there is a coronal mass ejection sort of unfolding as we speak. The likelihood of Earth vicinity coronal mass ejections has gone up a little bit. Can't even see the sunspot 2813 here. It's pretty small. It's pretty close to the northwestern limb. By the way, if you want to win a free month of Patreon, enter our slam poetry contest. Details at smashomash.com/forum. Thanks to our patrons, the true source of funding for the content, patreon.com/smashomash. Thanks to our new patrons. Thanks to our old patrons. Thanks to our returning patrons. As patrons get all the benefits. Thanks to Smash Team for tuning in. Remember to leave a comment, press share, press like, subscribe, etc. Tell your friends, foes, science noobs, and science pros about the channel. Here comes some more bonus features in the form of the latest colorized magnetogram. There's Sunspot 2813, looking like it's degraded just since we did show prep. And I'm not sure if that umbra has shrunk or not, but there's the intensity gram. There is the colorized magnetogram, looking pretty weak. And here are some full disk images to close things out. Thanks for tuning in, folks. Remember, stare at the sun. Attempt to understand the physics. Don't drink, and if you do, don't drive. Seriously, don't drive. I could be out there. And I enjoy light traffic. And since it'll never be now again, may that solar wind be at your back and that covidiously absent from your doorstep.